Now we're going to do another problem, this time with momentum in 2 dimensions. So let's set it up. First we've got a car that's moving east. The car's mass is 4,000 kilograms, traveling at 15 meters a second. We've got a second car, we'll call it B, with mass 1,000 kilograms. However, we don't know its initial velocity. Now, after impact, the two vehicles remain together, and they travel north 60 degrees east. Now, when they collide, they stick together with a combined mass of 5,000 kilograms. Now, this is obtained by adding A and B. Now, we also do not know the final velocity of the two objects. So we know by the conservation of momentum, the momentum initially in the system is equal to the final momentum of the system. So let's work out the initial momentum of each of the components. So let's start with A. So momentum of A is equal to mass of A times the velocity of A. This is 4,000 times 15, which equals 60,000 sec-newtons. Now let's work out B. So the momentum of B is equal to the mass of B times the velocity of B, which equals 1,000 times the velocity of B. Now we're going to leave it like this because we do not know what the velocity is. But what we do know is that the combined momentum of the system is a vector addition of A and B. So we can say the total is equal to momentum of A plus momentum of B. And we can say that these are vector quantities. Let's draw the vector addition. So this can be drawn to scale. However, I'm just going to use maths to work it out more accurately. So if we draw the momentum of A, which is 60,000 sec-newtons to the east, we have the momentum of B as well. Which we will write 1,000, and that's north. Okay, so now our vector component, the result will be from the start to the finish when we added the vectors. So this is our result, which is the total. Now this shows us that the initial momentum, the total initial momentum, is equal to PT, which is a combination of these vectors. However, with the conservation of momentum, we know that the initial momentum is equal to the final momentum. Now the final momentum is equal to the final mass of A plus B times the final velocity, which we do not know. So the final momentum will be 5,000 Bf. And as stated previously in the question, the angle would be 30 degrees. So now we can use this information that we've got to solve the equation. So using trigonometry, and what we know here, we are looking for this value here, the initial velocity of B. So we can use trigonometry to find that. So we can use the tan rule. So we've got tan of the angle, which is 30, is equal to the opposite side divided by the adjacent side. Solving this and rearranging the equation, we get the velocity is 34.64 meters per second, which is approximately 125 kilometers an hour, and this will be north. Now you can see we didn't end up really using this in our calculations, however it was necessary to prove the initial is equal to the final, so we can use the information that we know to calculate it.